In this lesson I will go through how you can use dot product as a Fresnel on object and also show you what the differences are between normal and true normal in Blender, and also a little bit what the difference is between camera and camera data view and so on, because we have a lot of different things but they sound and are almost the same thing. So let's start right away by taking away this plane. So just press delete and instead we will add a donut. So Shift A, go to mesh and select the torus here. So we have it in and we subdivide it. So go to the modifier properties, add modifier, subdivision surface, and I think we can subdivide it 3 times. And we go to object and we use shade smooth like this. Okay, so it looks good. And we don't need any empty this time, we only have this and the camera. So now we go to rendered view so we can see how it looks, and we also go to our material properties and add a new material, so we have that in. We take away the principle as usual and we add a texture coordinate. So Shift A, input, and a texture coordinate like this. And we add a dot product. So Shift A and then converter, vector math, and in that vector math we add a dot product. And we have learned before how we can use dot product to create light and shadows, but we can also use it to create Fresnel, which means that it can get darker or brighter at the edges of an object, because dot product is comparing the normal, the faces, the direct direction, and that we can use here as well. So if I take the normal from the texture coordinate into the dot product and I take the camera in here and put that to the surface, we get this very bright side, and that we get from the camera view here. So if I look at the camera like this, I get very much white here and I get some dark or even black inside here near the donut. And I think we can scale down the donut just a bit like that and press Ctrl A to rotation and scale, so we have it like this. So it doesn't work so very good, and that is because we need to normalize the camera here. So if I press Shift A now, and in converter I select vector math and put in the normalize, you can see we get a much softer now, not so bright, not so much glow. This is like white and black here. And we can also put in a power node here to control it a bit. So Shift A, converter, math, and we change this into power. So somewhere here we can find power, it's here. And by changing that, you can now see that we can change the inside so it looks really good. So we get that Fresnel or almost ambient occlusion thing with this combination here with the normalized camera view, because that is the camera view, and the normal for our object, and connect it using the dot product, and then we use power to add some contrast into it so it looks soft and so on. However, if I now change the rotation for this, so let's say that I press R and then Y, so I rotate it like this. You can see now when I stop rotating that it's completely black on the other side. So it only worked once. So to make this work again, I need to press Ctrl A and apply the rotation, and when I do that, now it works again because this has been updated. Okay, so why do we need to do all that stuff? That is very heavy, and it doesn't work if we want some dynamic and we want to move stuff. Well, that is how texture coordinate works. But we have another set of nodes called geometry nodes. So if I press Shift A and go to input and use the geometry instead, you can see we also have a normal here, exactly as we have in the texture coordinate. So is there any difference between those? Yes. So if we use the geometry, it doesn't look for how the textures are placed or how we should work with the object when it concerns texture. It looks on the physical geometry on this. So in most cases, if we have pressed Ctrl A and those things, then everything is exactly the same. But if I now take the normal from the geometry node, put this in here, you see no difference at all. But now I rotate this using R and Y, and you can see it changes dynamically. I don't have to press Ctrl A to do these changes for getting the Fresnel effect. I get it directly in my geometry here. So using the geometry data and the normal will automatically give me an updated view of the normal here from the camera view, since we're using the camera here. Then I also said something about true normal, and if you remember, I smoothened this out. So in reality we have a lot of faces here, but you can't see them because we have then faked and smooth normal. But the true normal still exists and it's behind. So if I change from normal to true normal here and put that into the dot product, you can now see the faces here, because now it's not smoothened. Now this is the raw normal from your model. So that is the difference between true normal and normal here. So that is really good to know, because normal here works in some way, normal here works in another way, because it looks right now at the geometry instead of just using, okay, this is for texture. And the true normal takes away the smoothness and use the raw normal that you have on your object. Okay, can we do more stuff? Yes, we can. So we can press Shift A again, and we can go to input and we can use camera here. I think we have camera data somewhere. There we have camera data. And if I use that instead of camera here, then you can see I can take it to the normalize here, but I can also take it directly to the dot product, and you see no difference. If I take the camera directly to the dot product without using the normalize, you can see the difference. So the camera data with the view vector is normalized. You don't need a normalized node to make it work. You can just put it in like this and it will work directly. So the camera data in the texture coordinate here is the raw data without any normalization, but you have normalized in the camera data here. So even if both are camera viewing vector, it is a difference between them. Okay, and then we can take the last thing here. If I now go here, I don't get the Fresnel to work as I would like to, and that is because we are working with the camera data. I would like to make this work with, whenever I change it, I would like this to be like, this is my window where I will look at stuff. So logically I think, okay, but then I can use the window here and put that in here, and I can then use that, and it worked the first time, as you could see, but after that it didn't work, and could be that I will need to normalize your things. So I put in converter, vector math, you put in your normalize, and okay, something happened here, but still when I move it around and then put it in, it doesn't follow along in a good way anyway. And that is because window is not what you should use. You should use incoming. if you use incoming, then it comes from the viewport right into our geometry here in like real time. So take away this one and use the incoming instead, and suddenly everything works. So now you can sit here in your viewport and have it in a good shape however you look at it. However, if you now should render it, then you need to understand that we need to have it for the camera. So then we have to change this back into either the view vector like this, or using the camera from here but with the normalize. I would suggest that you use the camera data view vector here. And you can of course change this power for all the stuff I went through right now to make it softer or make it less soft as you want to. So that is all I wanted to go through with you right now, but it's a lot, and you need to think a little bit about all this stuff because they seem similar, but they are not exactly the same. So geometry normal is not the same as normal from the texture coordinate, because normal or the texture coordinate is depending on the rotation that everything is like applied, and you don't need to apply it in the geometry. Then it's just looking at the object. How does it look right now in this moment when it comes to the normal? How is it facing against the z-axis that you can see directly in real time in geometry node, and you can't in texture coordinate. Okay, I hope you learned something in this lesson as well, and I will see you in the next one. So I just say bye for now.